2-megawatt 2 reactor. Denmark Copenhagen Atomics is a Danish molten salt technology company developing mass-manufacturable molten salt reactors. The Copenhagen Atomics waste burner is a single-fluid, heavy water-moderated, fluoride-based, thermal spectrum, and autonomously controlled molten salt reactor. This is designed to fit inside of a leak-tight 40-foot, 12-meter stainless steel shipping container. The heavy water moderator is thermally insulated from the salt and continuously drained and cooled to below 50 degrees Celsius, 122 degrees Fahrenheit. A molten lithium-7 deuteroxide 7-LiOD moderator version is also being researched. The reactor utilizes the thorium fuel cycle using separated plutonium from spent nuclear fuel as the initial fissile load for the first generation of reactors, eventually transitioning to a thorium breeder. Copenhagen Atomics is actively developing and testing valves, pumps, heat exchangers, measurement systems, salt chemistry and purification systems, and control systems and software for molten salt applications. In July of 2024, Copenhagen Atomics announced that their reactor is ready to be tested in a real-life scenario with a critical experiment at the Paul Scherrer Institute in Switzerland in 2026. Germany, 1980s. The German THTR-300 was a prototype commercial power station using thorium as fertile and highly enriched U-235 as fissile fuel. Though named Thorium High-Temperature Reactor, mostly U-235 was fissioned. The THTR-300 was a helium-cooled high-temperature reactor with a pebble-bed reactor core consisting of approximately 670,000 spherical fuel compacts each 6 centimeters, 2.4 in diameter, with particles of uranium-235 and thorium-232 fuel embedded in a graphite matrix. It fed power to Germany's grid for 432 days in the late 1980s, before it was shut down for cost, mechanical, and other reasons. India has the largest supplies of thorium in the world, with comparatively poor quantities of uranium. India has projected meeting as much as 30% of its electrical demands through thorium by 2050. In February 2014, GHE Bhabha Atomic Research Center, in Mumbai, India, presented their latest design for a next-generation nuclear reactor that burns thorium as its fuel ore, calling it the Advanced Heavy Water Reactor, HWR. They estimated the reactor could function without an operator for 120 days. Validation of its core reactor physics was underway by late 2017. According to Dr. R.K. Sinha, chairman of their Atomic Energy Commission, this will reduce our dependence on fossil fuels, mostly imported, and will be a major contribution to global efforts to combat climate change. Because of its inherent safety, they expect that similar designs could be set up within populated cities, like Mumbai or Delhi. The Indian government is also developing up to 62 reactors, mostly thorium-based, which it expects to be operational by 2025. India is the only country in the world with a detailed, funded, government-approved plan to focus on thorium-based nuclear power. The country currently gets under 2% of its electricity from nuclear power, with the rest coming from coal, 60%, hydroelectricity, 16%, other renewable sources, 12%, and natural gas, 9%. It expects to produce around 25% of its electricity from nuclear power. In 2009, the chairman of the Indian Atomic Energy Commission said that India has a long-term objective goal of becoming energy independent based on its vast thorium resources to meet India's economic ambitions. In late June 2012, India announced that their first commercial fast reactor was near completion, making India the most advanced country in thorium research. We have huge reserves of thorium. The challenge is to develop technology for converting this to fissile material, stated their former chairman of India's Atomic Energy Commission. That vision of using thorium in place of uranium was set out in the 1950s by physicist Homi Bhabha. In 2013, India's 300 megawatts WR, pressurized heavy water reactor, was slated to be built at an undisclosed location. The design envisages a startup with reactor-grade plutonium that breeds U-233 from TH-232. Thereafter, thorium is to be the only fuel. As of 2017, the design was in the final stages of validation. Delays have since postponed the commissioning criticality of the PFBR to September 2016, But India's commitment to long-term nuclear energy production is underscored by the approval in 2015 of 10 new sites for reactors of unspecified types, though procurement of primary fissile material, preferably plutonium, may be problematic due to India's low uranium reserves and capacity for production. Kamini Kalpakkam Mini Reactor is the world's only thorium-based experimental reactor. It produces 40 megawatts of thermal energy at full power.